A black hole is not black, and it is not a hole. Almost everything you picture when you hear those words, a dark pit in space, hungrily sucking in everything around it, is wrong. The truth is stranger than anything science fiction ever invented. And right now, a monster version of one is sitting at the center of our own galaxy, and you are orbiting it.
To understand what a black hole really is, start with a dying star. Take a star at least 20 times heavier than our Sun. For millions of years it burns, and the outward push of that burning perfectly balances the crushing pull of its own gravity. Then the fuel runs out. In less than a second, the core collapses, and if enough mass gets squeezed into a small enough space, something extraordinary happens. Gravity wins. Completely. The escape velocity, the speed you would need to break free, climbs past 300,000 kilometers per second. Faster than light. And since nothing in this universe can travel faster than light, nothing can leave. Not rockets, not radio signals, not light itself. That is the entire recipe. No exotic ingredients, no magic. Just gravity, pushed past a line that nothing can cross back over.
Here is the part that should unsettle you. We predicted these objects before we ever saw one. In 1915, just weeks after Einstein published his theory of general relativity, a German physicist named Karl Schwarzschild solved its equations while serving on the front lines of the First World War. His solution described exactly this, a region of space so warped that nothing could escape it. Einstein himself saw the mathematics and refused to believe nature would allow such a thing. He thought it was a mathematical curiosity, an abstraction that could never physically form. He was wrong. The universe had been building them for billions of years, in numbers we are still counting. Our own galaxy alone is estimated to contain millions of them, drifting silently between the stars. The monsters were real all along. We just could not see them, because by definition, they are the one thing in the cosmos built not to be seen.
That line of no return has a name, the event horizon. And here is the first thing almost everyone gets wrong. The event horizon is not a surface. There is nothing physically there. No wall, no membrane, no crust you could touch. If you fell through it, you would feel absolutely nothing. No bump, no flash, no warning. It is simply the invisible boundary where the universe quietly deletes your return ticket. You could cross it mid-sentence and never know. Here is the second thing everyone gets wrong. Black holes do not suck. They are not cosmic vacuum cleaners crawling through space, hoovering up galaxies. If our sun were somehow replaced this instant by a black hole of exactly the same mass, Earth would not spiral in. Nothing would change in our orbit at all. We would keep circling exactly as we do today, just in the cold and the dark. From a distance, a black hole's gravity behaves like the gravity of any other object with the same mass. You have to get absurdly, suicidally close before the strangeness begins. But when matter does get close, the show is spectacular. Gas and dust, spiraling toward the horizon, get whipped up to nearly the speed of light, grinding against each other and heating to millions of degrees. The result is a glowing whirlpool called an accretion disk, and it can outshine every star in its home galaxy combined. The brightest objects in the known universe, quasars,
are not stars at all. Each one is a feeding black hole, converting matter into raw light with an efficiency that makes nuclear fusion look feeble. So let's revisit the first half of our opening claim. A black hole is not black. Some of them are, quite literally, the most blinding objects in existence.
And then Stephen Hawking made it even stranger. He showed that quantum effects near the horizon should cause every black hole to glow faintly on its own, leaking a whisper of particles we now call Hawking radiation. Which means that even a completely isolated black hole, with nothing to feed on, is not perfectly dark. It shines. Barely. Slowly. But it shines. And that tiny glow, as we'll see, decides the fate of the entire universe.
Now, the second half of the claim. A black hole is not a hole. A hole is an absence, an empty space where something is missing. A black hole is the exact opposite. It is the densest, most concentrated presence in the cosmos. All the matter of that collapsed star is still in there, crushed into a region so small that our equations give up. General relativity says everything collapses to a single point of infinite density, a singularity. But most physicists suspect that infinite is not a description of reality. It is the mathematics waving a white flag, telling us our theory has broken and something deeper is hiding underneath. A black hole is not a hole in space. It may be a hole in our understanding.
And the strangeness does not stop with space. It infects time itself. Einstein showed that gravity bends time. The stronger the gravity, the slower a clock runs. Near an event horizon, this effect becomes monstrous. Imagine watching a friend fall toward a black hole. You would see them slow down, then slow further. Their image would stretch, redden, and dim until they appeared frozen at the horizon, fading like a photograph left in the sun. From your side, they never quite fall in. But from their side, they fell straight through in seconds, noticing nothing at all. Both stories are true. That is not a paradox. That is simply what time does when gravity gets extreme enough. What happens next depends entirely on the black hole's size, and it is the opposite of what you would guess. A small, star-sized black hole is the dangerous one. Its gravity changes so violently over short distances that your feet would be pulled millions of times harder than your head, stretching you into a strand of atoms. Physicists genuinely call this spaghettification. But a supermassive black hole, millions or billions of times the sun's mass, is gentler at the doorstep. Its horizon is so vast that the tidal forces there are mild. You could drift across the point of no return alive, intact, and completely unaware that the rest of the universe just lost you forever.
And these giants are not hypothetical. In the constellation Sagittarius, 26,000 light-years from where you are sitting, sits Sagittarius A star, a black hole 4 million times the mass of our Sun, anchoring the entire Milky Way. Every star in our galaxy, including ours, orbits it. Astronomers have watched stars whip around it at thousands of kilometers per second. And in 2022, the Event Horizon Telescope captured its actual image, a ring of superheated light bent around a circle of nothing. 3 years earlier, the same project photographed an even bigger one in the galaxy M87, 6.5 billion solar masses. We didn't just theorize these monsters, we have looked them in the eye. So think back to the picture in your head when this video began. A black pit in space, sucking everything in. Now you know better. Not black. Some are the brightest things that exist, and even the quiet ones softly glow. Not a hole, but the densest object reality allows, wrapped around a place where physics itself breaks down. Not a destroyer prowling for prey, but the silent anchor that holds our galaxy and you in orbit.
And here is the ending no one expects. In the unimaginably far future, long after the last star has burned out and the last planet has gone cold, black holes will be the final objects left in the universe. And then, thanks to that faint Hawking glow, even they will slowly evaporate over timescales so vast that writing the number of years would take a wall of zeros. The darkest things in the cosmos will be its last light, quietly whispering themselves away into nothing.
But that is not a sad ending, because it means we live in the brief, brilliant era when there is still something to see and someone to see it. A species of curious apes looked at the one object in nature designed to hide everything, an object that swallows light itself, and we figured it out anyway. We weighed it, photographed it, and mapped the edges of its mystery.
If we can drag the truth out of a black hole, there is nothing in this universe we cannot eventually understand. There is one more question, though, the one physicists argue about most. What happens to the information of everything a black hole swallows? The answer might rewrite physics itself. That is a story for the next video.